In this question, we're analysing a game of squash. We start with a squash ball that has a mass of 0.1 kilograms moving towards a player with a velocity of 20 meters per second, and I'm showing that here in a diagram. Let's calculate the momentum before the ball is hit by a racket. So P is equal to mv, and we can substitute. The mass is 0.1 kilograms and the speed is 20 meters per second. That means that the momentum before the collision is 2 kilogram meters per second. Now, when the ball is hit by the racket, it changes direction. It moves in the opposite direction and it travels at a speed of 40 meters per second. So let's calculate the momentum of the ball after it's been hit by the racket. Again, it's given by mv. Now the mass hasn't changed, but the ball has changed direction. So we have minus 40 for the velocity of the ball rather than 40. That gives a negative momentum. We find that the momentum after it's been hit by the racket is minus 4 kilogram meters per second. Now this is an impulse question we're looking at, so we need to find out the change in the momentum of the ball. And we do that by taking the momentum after the ball has been struck and subtracting from that the momentum that the ball had before it was hit by the racket. In other words, we have minus 4, take away 2, so our answer is minus 6 kilogram meters per second. Now, what's the significance of the minus sign? It means that the change in momentum is all towards the left, i.e. it's all away from the original direction of travel. Now, the impulse is given by the force multiplied by the time it acts. That's F delta t, and that's equal to m delta v, which we've just worked out. That's the change in momentum. So F delta t is also equal to minus 6. We can rearrange to get F equal to minus 6 divided by delta t. Delta t is the time that the racket and the ball are actually in contact, and we're told in the question that they're in contact for 50 milliseconds. If we write that in seconds, we find that delta t is equal to 0.05 seconds. So let's put that number into our equation then. The force is going to be minus 6 divided by 0.05 seconds. That gives us a force of minus 120 newtons. Again, note that we have a minus sign. That just tells us that the force acts in the opposite direction to the initial velocity of the squash ball.